Very important both in your board exam class 11 and 12 students as well as in your JEE mains and advanced. This modulus and conjugate number from complex number. This topic is very important. So this is the 5th class on complex number. I suggest you to go through all the 4 sessions on complex number I have covered prior to this. I am going to complete this modulus and conjugate number in 2 classes. Today's class I will give you the concept of modulus and conjugate number, both algebraic standpoint as well as from geometry standpoint. And in the next class I will explain the properties of modulus and conjugate number. These 2 classes, if you follow properly, your chapter is closed. You can answer any question on modulus and conjugate number, and this is absolutely 95% cases you will get question both in your JEE as well as board exam. So please go through the entire video and understand your concept, and I will give few examples also. Okay. So hi, Debashish again from Devs Learning Hub, my YouTube channel Devs Learning Hub and my Facebook page too Devs Learning Hub. So जब complex number हम लोग बोलते हैं, in my previous videos already I have said complex number, always we think about the standard form of a complex number. So what is the standard form of a complex number? That is a plus ib. One is real part, one is imaginary part, right? So let's say there is a complex number z where z equals to a plus ib. Which is the real part? Real part is a. And which is the imaginary part? That is the b. So modulus of z, that is how we will represent, or we can say it is mod z in short form. Mod z or modulus of z, that is equals to root over a square, that is the real part square, square of the real part plus square of the imaginary part, here it is b square. So root over a square plus b square, that is the absolute value or mod of that complex number or modulus of that complex number. So sometimes this mod z, this is called mod z, or we can say this is modulus of z, or we can say this is absolute value of the complex number, absolute value of z. Right? So that is how we can represent the mod or modulus or absolute value of a complex number. Now it is the conjugate number. Now how to represent or calculate conjugate number? Conjugate number is represented like with horizontal bar. So in modulus of z we say that's how we represent vertical bar, both sides, and conjugate of a complex number, it is represented by the horizontal bar, right? So conjugate of z is nothing but the conjugate. Let's say if we say a plus b, what is the conjugate number of a plus b? That means a minus b. So conjugate of the complex number is of a plus ib, that is equals to a minus ib. What is the conjugate number? Conjugate of a complex number is represented with z horizontal bar, and that is thus the sign is reversed. A plus ib, the conjugate number is a minus ib. If the complex number is a minus ib, then the conjugate of the complex number will be a plus ib. Right? So what you can say, see the fun that more complex conjugate, see conjugate number of z is a minus ib, right? That means if I say conjugate z of conjugate, so second time I am taking the conjugate of this, that means again it is a plus ib, because the conjugate of z means conjugate of a minus ib. Conjugate of a minus ib, that is equals to conjugate a plus ib. That means a plus ib equals to z. That means conjugate of z of conjugate, that is equals to z. Got it? Very interesting thing. you will see later on when I will come to the properties of complex conjugate and modulus, right? Now I will show you a very interesting topic, the geometrical interpretation of modulus or conjugate number, right? Let's say just like Cartesian plane, x-axis and y-axis. In Cartesian plane, what we know? This is x-axis and this is y-axis. But to represent any complex number, we need to take one real axis and vertical one, which is the y-axis in Cartesian plane, that is the imaginary axis. Now let's say there is a complex number z which is equals to a plus ib. ये जब हम लोगों को रिप्रेजेंट करेंगे, जो कार्टेशियन प्लेन जो होता है हम लोगों का हॉरिजॉन्टल एक्सिस इज x and vertical axis is y. Here we will treat the x-axis as the real part of the complex number and the y-axis we will take as an imaginary. This is the, because this plane is the imaginary plane, because one part is real, one part is imaginary. So y-axis will be will be treated as the imaginary axis and the x-axis will be treated as the real axis. That means x part will represent ये जो real part of the z, ये represent होगा through x-axis. और imaginary part of z, the complex number, imaginary part of the complex number, that will be represented by the y-axis. This is IMZ will equivalent to Cartesian axis. That is how I am comparing. ठीक है? तो अब आपको ये नंबर को प्लॉट करना पड़ेगा. तो कैसे इसमें ये ग्राफ में कैसे देखना पड़ेगा? ये देखने में ऐसा लगेगा, जो ये पॉइंट मान लो P is the point which is a plus IB, represent this one. So that means if you draw a perpendicular from here, and that will intersect the real axis Q. This origin, that's the intersection of the real x and y axis. Here it is the real axis and the imaginary axis. A origin is O, that is equivalent to 0, 0, right? So if you connect now this O and P, you are connecting, that means this triangle OQP, this is a rectangle triangle. So now if it is a rectangle triangle, in that case what I can say, OP is the hypotenuse, this one is the hypotenuse, that is equals to root over OQ square plus PQ square. What is OQ? OQ is nothing but the real part of the complex number, because this is the real axis. So OQ is A and PQ is B. So therefore this OP will be root over OQ square plus PQ square, that is equals to root over A square plus B square. That is how we represent complex number. And what is this root over A square plus B square? That is mod Z. What we learned just few minutes back, that if Z is a complex number represented by A plus IB, then modulus of Z, that is equals to root over A square plus B square. अगर modulus of Z equals to root over A square plus B square, that means OP equals to modulus of Z. तो ये जो वैल्यू है A plus IB and this is 0, 0. That means if you remember the formula in coordinate geometry, जहां पे दो पॉइंट का बीच में डिस्टेंस कितना है, अगर आपको कोऑर्डिनेट्स वो दो पॉइंट का बोल दिया गया, तो यहां पे 0, 0 and this is AIB, right? That means it is root over A square plus B square. Then how we can represent this? Root over A square plus B square means root over A minus 0 whole square plus b minus 0 whole square. That means this is the distance between these two formulas. So actually the modulus of the complex number or the absolute value of the complex number, it represents distance between 2 points. So modulus of z or absolute modulus of complex number or absolute value of complex number, that represents the distance between 2 points. Got it? So that is the geometrical interpretation. I will show you one more thing in this context. Then I will come to conjugate number, geometrical interpretation. Okay. Now let's say there are two complex numbers. Z1 is a plus ib and Z2 is c plus id. See, very interesting. Okay. Now you will plot these two numbers first in the complex plane, and this imaginary plane is also termed as Argand plane. What it is called? Argand plane. Okay, just remember this term. Okay, now Z1 a plus ib, that means real part is a, imaginary part is b. That means along the real axis it is a, and along the imaginary axis it is b. So this point is actually AB, or you can say, just consider the distance, forget about the imaginary part, AB, right? And with respect to second complex number Z2, C and ID, so C plus ID, real part is C and imaginary part it is D. So that means this point is C and D, X and Y axis. Compare, just think about X and Y axis. AB, X coordinate X, A, Y coordinate B. Here it is X coordinate C, Y coordinate D. Just in place of Y coordinate, we'll think about the imaginary axis. Okay. Now, based on your previous knowledge, coordinate geometry जो है, तो ये point जो है, that is Z1. Or let's say this point is represented as P, this point is represented at Q. Now what is the distance between these 2 points as per your coordinate geometry formula? What is the distance? So PQ equals to root over x2 minus x1 whole square and y plus y2 minus y1 whole square. That means a minus c whole square plus b minus d whole square. So PQ equals to root over a minus c whole square plus b minus d whole square. That is the distance between 2 points. Those are on the complex plane. Now we will calculate mod of Z1 minus Z2. First you calculate Z1 minus Z2. So here it is Z1 minus Z2, that is equals to a plus ib minus of c minus of id, right? So if you separate the real part, a minus c and plus I into b minus d. That is how it looks like. Now if I say mod of Z1 minus Z2. So what is the definition, how to calculate mod? Mod is square root of square of the real part plus square of the imaginary part. That means here it is root over a minus c whole square plus b minus d whole square. Mod of Z1 minus Z2 equals to root over a minus c whole square plus b minus d whole square. And the same thing here is the distance between these 2 points. With respect to coordinate geometry, it is also a minus c whole square plus b minus d whole square. So these two are same. That means mod represent the distance between 2 points. So if there are 2 complex numbers are given and you subtract one from the other and take the modulus, then actually it is saying the distance between those two complex numbers, both those 2 points in the Argand plane or the imaginary plane. Got it? So modulus is nothing but the representation of distance with respect to geometry. Now I will show you what is the geometrical representation of conjugate number. Okay, so now see the complex number, it is a plus ib, z equals to a plus ib. What did I say for to find out the conjugate? That means the conjugate of this complex number will be a minus ib. Now you place both of these complex number in this Argand plane, right? This is the Argand plane where it is the real axis along the x-axis and imaginary axis along the y-axis with respect to Cartesian plane, right? So this is the origin. So when you will plot this a plus ib along the real axis, it is a, and along the imaginary axis it is b. That means this point is actually a, b. When you will represent this a minus ib, that means it will be in the fourth quadrant, x positive, y negative, right? So this is same thing here, a minus ib, this point is a minus b. That means the conjugate number, so this is actually z equals to a plus ib, and this is actually conjugate of z, that is equals to a minus ib. So conjugate number is actually the reflection point on the mirror. So conjugate number is, with respect to geometry, it is representing the reflection of the point in the mirror reflection. Got it? So that is what the geometrical interpretation of mod z is, the distance between 2 points. Geometrical representation of conjugate number is the mirror reflection of a point. If there are two complex numbers, z1 that is equals to a plus ib, and another complex number z2 that is equals to c plus id, then z1 minus z2 that is equals to a minus c plus I of b minus d, and mod of z1 minus z2 that is equals to, therefore, root over of real part square, that is a minus c whole square, plus imaginary part square, that is b minus d whole square, which is nothing but the distance between these two points in the complex plane or Argand plane. So modulus actually define the distance with respect to geometry. Now with respect to geometry, the conjugate number, how it is represented? If there is a complex number z equals to a plus ib, then the conjugate of that z is a minus ib. So a plus ib in the graph, it is the real axis and it is the imaginary axis. Now if I place these two numbers here, then it will be the z1, this is a plus ib, z equals to a plus ib, where a is along the x-axis, b is along the y, this is b, this is a, and when it is conjugate of z, that means a minus ib. So same real part, but the imaginary part will be minus ib, so it is in the fourth quadrant, so it is minus b. So this point is a minus ib and this point is a plus ib. So conjugate number, it reflects the mirror reflection, whereas modulus represents the distance between 2 points. Got it? So if you like this video, please click on the like button, and if you would like to have this kind of video again and again as the notification as soon as I upload, Please subscribe my YouTube channel Devs Learning Hub and follow my Facebook page to Devs Learning Hub. This is very important topic.